Okay, problem number 63. Frank's 6 feet tall. He's on a stage with a spotlight in the corner. And as Frank moves across the stage, his shadow moves across the stage. They ask us when Frank is 10 feet away from the left end of the stage, how fast is the tip of his shadow moving? And they tell us that Frank is moving at 3 feet per second. Well, let's look at this diagram here. You can see the spotlight is 30 feet above the stage. And we've got a right triangle here. I'm going to draw that a little larger so we can scribble on it, and you can see. Okay, so we've got 30 feet here. We know Frank is 6 feet tall. So in here, let's let this represent Frank. I'm not going to try to draw Frank. 6 feet tall. We know that this part of the stage is going to be 10 feet at the moment we're discussing. But as Frank moves, this is going to change. So let's call this, how about X? And down here we have an unknown. We have an unknown length down here. Now, we don't know how long Frank's shadow is. Don't want to call that X also, but we can't really use X for two different lengths. So let's call this X1 and X2, X sub 1 and X sub 2. If you want to use different letters, that's up to you. Well, it looks like we can set up a proportion. We can say that Frank's height of 6 feet over the shadow, X2, that's going to equal the distance from the stage to the spotlight, 30 feet, over this total distance here, X1 plus X2. This doesn't seem to help us very much. Let's see if we can clean anything up here. Let's cross multiply now. So we're going to have 30 times X sub 2, and that's going to equal 6 times the quantity X sub 1 plus X sub 2. Let's divide both sides by 6. So 5 times X sub 2 equals X1 plus X2. We can combine some like terms here. Let's subtract X2 from both sides. 4 times X sub 2 equals X sub 1. Doesn't look like it the way this diagram is drawn. Yeah, maybe it does. All right. Well, let's think about what we can do with this information here. When Frank is 10 feet from the left end of the stage, his shadow is going to be, let's see here, divided by 4. 10 divided by 4 is 2.5 feet. All right. Now, I don't know if that helps us, but we've got it. We've got our two little right triangles here. They're similar, so we have proportions. Well, they tell us that Frank's moving at 3 feet per second, so that's got to mean something here. Let's use our Pythagorean theorem. And just reduce some of our scratch work to give us a little more room to work. I'm going to change plans. Instead of using the Pythagorean theorem, let's look back up here and say Frank is walking, he's walking from left to right. Okay. He's walking from left to right, so he's going that way. And I'm saying he's moving at a rate of 3 feet per second. So here's what we know. We know that dx sub 1 dt equals 3 feet per second. Okay. And we want to know how fast the shadow is moving. So we want to know what dx sub 2 dt when x sub 1 equals 10. Well, we can do this. Take the equation we have right here and find its derivative. The derivative of 4x sub 2 is 4 dx sub 2 dt. The derivative of x sub 1 is dx sub 1 dt. Okay. We can substitute here. Put 3 in place of dx sub 1 dt. there's enough room down here. There it is. Okay, and now we're going to divide by 4 to get the x sub 2 dt by itself. So this is moving at 3/4 of a foot per, what was the unit? Second? Okay, now what we have to take into account is Frank is moving and the shadow is moving. So let's take and add dx sub 1 plus dt plus dx sub 2 dt to get the rate at which the tip of the shadow is moving. Okay? That's going to be, what, 3 plus 3/4, or 3 3/4, 15/4 feet per second. See what that matches? It matches option C. That was a challenge. I'll tell you, if I was doing this in a hurry, I probably would have selected B because I saw the answer there. But this was a challenging problem. Thanks for trying your hardest. Keep on working hard. You can do well. You can certainly do well. Good luck with the rest of your work.